Hey guys, welcome back. This time around we want to continue our discussion on biochemistry. In particular, we want to look at all those inorganic compounds other than water. Those inorganic compounds other than water are salts, acids, and bases. We've taken a look at salts before when we talked about ionically bonded compounds. A salt is going to be an energy relationship between a metal and a nonmetal, in which the metal will transfer one or more electrons to the nonmetal, and the nonmetal will receive one or more electrons. Now, remember that in a dry state, it crystallizes out, but when placed in the water, those bonds break, creating charged ions that we call electrolytes. There are two types of electrolytes. There are the positive charged cations, which are going to be your metals that have donated one or more electrons, and there are the negative charged ions known as anions, which are going to be the nonmetals that have received one or more electrons. Now, these electrolytes are very essential to us. They do not determine pH or anything like that, but they are going to govern what kind of electrical currents we can have in our body. They do give us net charge potential. Key electrolytes are going to be sodium, potassium, calcium, magnesium. Now, how do salts differ from acids and bases? Acids and bases are actually modified salts in that they are a relationship between a metal and a nonmetal, and it's an ionically bonded relationship. But in the case of an acid, when placed in the water, it will separate out, and its cation is going to be a hydrogen plus. In the case of a base, the anion is always going to be an OH group. Now, the key thing that you got to appreciate with acids and bases is that acids and bases will determine our pH in our body. And pH is important because it's one of those key characteristics associated with effective enzyme activity. Because if I change the pH of my body just slightly, we're going to see enzymatic activities change quite a bit. So what is this pH? And it's important then to measure this pH. pH is going to be the free hydrogen ion concentration or relatively free hydrogen ion concentration in a solution. In this case, the solution typically we think of as being our blood. We measure pH on a scale of 0 to 14, with 7 being neutral. Pure water has a pH of 7 because it has an equal concentration of hydrogen ions and OH groups, because water is H2O. Anything that is less than a pH of 7 we would consider to be acidic because it has more free hydrogen ions than it has free OH groups. Anything greater than a pH of 7, going from a pH of 7.01 down to 14, is going to be basic or alkaline. The closer it is to 14, the stronger the base. The closer it is to 0, the stronger the acid would be. Now, the pH is important for us to modify and be able to adjust throughout, because take a look at some of the examples of things that have pHs that are different from what our blood is. Our blood has a pH of 7.35 to 7.45 in the ballpark. Now notice that we can see a lot of acidic things that I eat on a daily basis. I love Mexican food, but notice where your citric acid is at. Notice where your tomato juice is at. Those things are very acidic. Introduction of these free hydrogen ions into my bloodstream should kill me if I don't have something that would allow me to buffer them out. Fortunately, I do. That's something that I have is actually called a buffer. The most common buffer is something known as a bicarbonate ion, carbonic acid buffer mechanism. And this is actually going to be a weak acid, weak base that can accept excessive hydrogens or excessive OH groups, pulling them out of the blood and neutralizing their effects as they're transferred into blood by binding to them. And where does the bicarbonate ion and carbonic acid come from? Well, actually, it's the way we carry carbon dioxide from the cells back to the lungs to exhale it. So we're actually carrying gas back to the lungs to exhale, and we're using it as a buffer as we do that transfer back. Pretty ingenious, if you ask me. Now it's time for you to step back a little bit and reflect on what biochemistry is, what the type of inorganic compounds are, what's the difference between water, salts, acids, bases, what is pH on a very basic level, and what are the benefits of buffers. See you later.